All right, so this is the 2019 AP Calculus exam. This is question number 1. It was on both the AB and the BC exam, and I'm solving these in real time. I've never read the questions before, so I may have to stop and think for just a second if a problem throws me for a loop. Hopefully I won't embarrass myself. So I'm looking at number 1. It gives you a rate that fish are entering a lake. Fish leave the lake at a rate modeled by L. They enter at a rate modeled by E. So I'm going to go ahead and make note to myself that the rate that the fish are going into the lake is E of T, and I will store that in my calculator for F1. My rate out, I will say it is L of T, which I will store in F2. So let me go ahead and plug those into my calculator. So E is 20 plus 15 sine of pi t over 6, pi x over 6. Double check, make sure I plug that in correctly. I did. F2 is going to be my rate out, which is 4 plus 2 to the power of 0.1 x squared. Enter. So those are now stored. Back to my workspace here. E and L are both measured in fish per hour. So I'll make note of units, fish per hour, and T is hours since midnight, or hours after midnight, which is defined as T equals 0. Okay, so question A, how many fish enter the lake over a 5-hour period from midnight to 5 a.m.? Give your answer to the nearest whole number. So you want the number of fish who have entered. That would be the antiderivative of the rate that they enter on the interval 0 to 5. And so I'll go to my calculator and punch that in. You're expected to do definite integrals in the calculator. You must show the setup, but you do not have to show the actual antiderivative, which you could do this one by hand. It's a U sub question. So 0 to 5 of F1, I'm going to go ahead and hit Control Enter to force the decimal, and it's 153.4, which would round to the nearest whole number of 153 fish enter on the interval 0 to 5. I guess we're including, doesn't really matter. All right, number B. What is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5 a.m.? So the average number that leave per hour, that's your average value theorem. That's going to be the average of the rate. So 1 over 5 minus 0, 0 to 5. And it's average number of fish that leave per hour. So yeah, this is right. So we are leaving at L of t dt. So this integral right here will give you the number of fish that left, and then we'll divide it by the 5 hours to get the average number per hour. So I'll punch that in the calculator. So control divide 1 over 5 times the antiderivative from 0 to 5 of the rate out, which is F2. Hit Control Enter to force the decimal, and it is 6.059. Did they ask us to round? What is the average number that leave? No, there is no rounding. So 6.059 fish per hour. All right. Part C. At what time t on 0 to 8 is the greatest number of fish in the lake? So we want the maximum of the actual number of fish in the lake. That will be a combination of both rate in and rate out. So they did not define a function for the amount of fish. So I'm going to say let's let A of t equal the number of fish in the lake. Or is it a pond? The lake. That's the total number of fish in the lake. I want the maximum of that function A of t, and the overall rate of change of A is going to be your rate in minus the rate out. So A prime is going to be E of t minus L of t. And if you want the maximum on a closed interval, you need to find critical numbers, which would be when E of t minus L of t is equal to 0, or you could say that's when E of t is equal to L of t, you must write down that equation that yields your critical numbers. And I'm going to solve that by finding their intersection on the graph. So back to my graph, and I am now going to have to adjust my window. So we are going from 0 to 8. So I'll change my window x's from 0 to 8, and my y's, I don't know. We're not going to have a negative number of fish. Oh, it's a rate, though. You could have, well, the rates were both positive. Let's go 0 to 20. I don't know. Just make up a number. Looks like they intersect once right there. So menu, analyze, intersection, right there. And I now have where they cross is 6.20356. I'm going to store that because I will use that answer in just a minute. So 6.2035, which I am storing that for A. Let A equal 6.2035. And then we now need to see at what time, what is the question? At what time is the greatest number of fish in the lake? Why isn't this grouping? There it goes. And so I'm going to find the actual number of fish at all of the candidates. You want to test your endpoints, and you want to test your critical numbers. And there we go. So A of 0. Let's see, I need to know how many fish we start with. Fish enter a lake at a rate given by that. Fish leave at a rate given by that. E of t and L of t are measured in fish per hour. E of t is measured how many fish enter. Okay, we do not have an initial amount, which is changing my approach, because usually what I'll do is I'll start with my initial amount plus like A of my critical number A. I would do my initial amount plus 0 to A of my overall rate of change. The problem is we don't have an initial amount. So what I'm going to do, I'm going to go first derivative test here. And what's going to happen, what I'm hoping happens, is that we find that the number of fish is increasing until the critical number and decreasing after, which would make the critical number the maximum. So extreme value theorem, while this is an extreme value theorem question, we don't have a way of getting actual numbers because we don't have that initial amount, that initial condition. So if that's my critical number, I'm going to make a number line for A prime. My critical number is 6.204. Remember, the number line is absolutely 100% invisible. I'm going to find my overall rate of change at 0, which would be E of 0 minus L of 0, and I need to determine if that's a positive or negative number. So back here, it's F1 of 0 minus F2 of 0. Control enter. That is a positive value, so that was 15. That is greater than 0, so the left side of my critical number we are increasing. I'm now going to test the right side, so I'll find A prime of 0. Let's make that 7. 7. So E of 7 minus L of 7, and that's going to give me something negative, but I have to find the value, or I'll feel better if I find the value. Escape. Okay, let's just go back and do this. 7 minus F2 of 7, control enter, and we get negative 21.357. That is a negative value. Okay, and now I know that my critical number at time 6.205, that must be the maximum because my function is increasing until the critical number and decreasing after. It does ask you to justify the question, so I'm going to say that the amount of fish number of fish, what does it say? The greatest number of fish. Okay, so the number of fish increases on the interval 0 to my critical number of A, which I've defined as A over here, because E of t minus L of t is positive on that interval, and decreases on the interval A to 8 because E of t minus L of t is negative on that interval. Therefore, the maximum occurs at t equals 6.2035 hours after midnight. You could also say, well, I wouldn't want time. I was going to say 6 something a.m., but I don't want to convert 0.2035 to time on a clock. So that many hours after midnight, and there is our final answer. I really wish they gave us an initial condition because testing the values at the candidates through the net change theorem is a little bit easier than what I just did. And I thought that was it, but that was question C. So now question D is the rate of change in the number of fish increasing or decreasing. Okay, so it's not the number of fish increasing or decreasing, it's the rate of the number of fish increasing or decreasing. And the rate of the number of fish increasing or decreasing, that's actually a second derivative question. And so we're going to find E prime of, and we're looking at 5, minus L prime of 5. And so we're finding the second derivative. Basically, we're doing a double prime of 5, because that will tell me if the rate is increasing or decreasing. And when I punch that in, we get, so, we're going to have to do derivative at a point here. So menu, calculus, derivative at a point. I want to find the value at 5 in the first derivative of f1 of x. And I can go ahead and do minus f2 of x. Let's go ahead and get both of those at once. So the derivative of f1 minus f2 at 5, control enter, we get negative 10.7227. That is a negative number, therefore the rate of change in the number of fish is decreasing, because, I guess I'll say this, because E prime of 5 minus L prime of 5 is negative. There we go, and I'm done with question 1 in 12 minutes.